According to the National Electrical Code, any line voltage power and all signal wires must be contained in metal conduit. This is because line voltage wires can pose a serious electrical hazard if they are not properly protected. In this situation, there is a two-conductor cable that will see a variable voltage of between 15 volts AC and 115 volts AC with a maximum volt-ampere power of 0.2 watts. This is a relatively low power application, but it is still important to follow the National Electrical Code guidelines. There are a few ways to avoid the expense and complication of using metal conduit. One option is to use a listed low-voltage cable. Low-voltage cables are designed to operate at voltages below 50 volts AC, and they do not require conduit. Another option is to use a shielded cable. Shielded cables have a metal shield that surrounds the conductors, which helps to protect them from electrical interference. Shielded cables can be used in non-conduit applications, but they are more expensive than unshielded cables. If you are unable to use a low-voltage cable or a shielded cable, then you will need to use metal conduit. Metal conduit is the most effective way to protect line voltage wires from electrical hazards. When considering electrical installations and wiring methods, understanding the National Electrical Code, or NEC, is essential. The NEC provides comprehensive guidelines to ensure electrical safety and prevent hazards. Conduit serves as a protective enclosure for electrical wiring, shielding conductors from physical damage, moisture, and other environmental factors. It also provides a path for pulling or installing wires. Various types of conduit are available, each suited for specific applications and environments. Metal conduit, such as rigid metal conduit or RMC, intermediate metal conduit or IMC, and electrical metallic tubing or IMT, offers robust protection and is commonly used in industrial and commercial settings. Non-metallic conduit, such as rigid polyvinyl chloride conduit or rigid PVC, and electrical non-metallic tubing, or ENT, is lightweight and corrosion resistant, making it suitable for underground and damp locations. The NEC specifies when conduit is required based on factors such as voltage levels, wiring methods, and environmental conditions. Generally, conductors operating at higher voltages or installed in locations subject to physical damage must be protected by conduit. However, there are exceptions for certain low-voltage applications or wiring methods that provide equivalent protection. The choice between metal and non-metallic conduit depends on factors such as the environment, the type of wiring, and the specific requirements of the installation. Metal conduit offers superior mechanical protection and can serve as an equipment grounding conductor, while non-metallic conduit is corrosion-resistant and easier to install. When selecting conduit, it's important to consider the size and number of conductors to be installed. The NEC provides guidelines for conduit fill, which specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors. Proper conduit fill ensures adequate space for heat dissipation and prevents damage to the conductors. In addition to conduit, other wiring methods, such as cable trays, wireways, and direct burial cables, may be used in certain applications. Cable trays provide support and routing for large quantities of cables, while wireways offer a protective enclosure for conductors in industrial settings. Direct burial cables are designed for underground installation without the need for conduit. Understanding the NEC requirements for each wiring method is crucial to ensure compliance and safety. Electrical safety is paramount when working with electrical systems. Always de-energize circuits before performing any work and follow lockout-tagout procedures to prevent accidental energization. Use appropriate personal protective equipment, such as gloves and eye protection, to protect yourself from electrical hazards. If you are not qualified to perform electrical work, consult a licensed electrician to ensure the installation is safe and compliant with the NEC. Regular inspection and maintenance of electrical systems are essential to identify and address potential hazards. Check for damaged wiring, loose connections, and corroded components. Replace any damaged or worn parts promptly to prevent electrical failures and ensure continued safety. Stay informed about updates to the NEC and other relevant electrical codes and standards. Attend training courses and workshops to enhance your knowledge and skills. By following best practices for electrical safety and adhering to the NEC requirements, you can create a safe and reliable electrical system for your home or business. When dealing with electrical systems, understanding concepts like voltage, amperage, and wattage is crucial. Voltage, measured in volts, is the electrical potential difference that drives the flow of current. Amperage, measured in amps, is the rate of flow of electrical current. Wattage, measured in watts, is the measure of electrical power consumed or produced. These three quantities are related by Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. Understanding Ohm's law allows you to calculate the voltage, current, or resistance in a circuit if you know the other two values. For example, if you have a circuit with a voltage of 120 volts and a resistance of 10 ohms, you can calculate the current by dividing the voltage by the resistance, which gives you 12 amps. The wattage in a circuit can be calculated by multiplying the voltage by the current, or watts equals volts times amps. For example, if you have a circuit with a voltage of 120 volts and a current of 12 amps, the wattage would be 1440 watts. When working with electrical systems, it's important to understand the different types of circuits, such as series circuits, parallel circuits, and series parallel circuits. In a series circuit, components are connected in a single path, so the current is the same through all components. The total resistance in a series circuit is the sum of the individual resistances. In a parallel circuit, components are connected in multiple paths, so the voltage is the same across all components. The total resistance in a parallel circuit is less than the smallest individual resistance. Series parallel circuits combine elements of both series and parallel circuits. Understanding how to analyze and calculate the voltage, current, and resistance in different types of circuits is essential for troubleshooting and designing electrical systems. Electrical grounding is a critical safety measure that helps to protect people and equipment from electrical shock. Grounding provides a low resistance path for fault current to flow back to the source, causing the circuit breaker to trip and energize the circuit. Grounding also helps to stabilize voltage levels and reduce electrical noise. There are two main types of grounding systems: equipment grounding and system grounding. Equipment grounding connects the metal enclosures of electrical equipment to ground, providing a path for fault current to flow back to the source. System grounding connects the neutral point of the electrical system to ground, providing a reference point for voltage and helping to stabilize voltage levels. Grounding electrodes, such as ground rods and ground plates, are used to connect the grounding system to the earth. The NEC specifies the requirements for grounding electrode systems, including the size and type of grounding electrodes, as well as the methods for connecting them to the grounding system. Ground fault circuit interrupters, or GFCIs, are another important safety device that helps to protect people from electrical shock. GFCIs monitor the current flowing in a circuit and quickly interrupt the power if they detect a ground fault, which is a leakage of current to ground. GFCIs are commonly used in bathrooms, kitchens, and other wet locations where there is a higher risk of electrical shock. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges, which are sudden increases in voltage that can damage sensitive electronics. SPD divert excess voltage away from the equipment, protecting it from damage. SPD are commonly used to protect computers, televisions, and other electronic devices. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. Circuit breakers and fuses interrupt the flow of current if it exceeds the rated value, preventing damage to the wiring and equipment. The NEC specifies the requirements for overcurrent protection, including the size and type of circuit breakers and fuses, as well as the methods for installing them. Understanding the principles of overcurrent protection is essential for ensuring the safety and reliability of electrical systems. The electrical wiring involves the installation of conductors to carry electrical current from the source to the load. Conductors are typically made of copper or aluminum, and they are insulated to prevent electrical shock. The NEC specifies the requirements for electrical wiring, including the types of conductors that can be used, the ampacity of the conductors, and the methods for installing them. The ampacity of a conductor is the maximum amount of current that it can carry safely without overheating. The NEC provides tables that list the ampacity of different types of conductors based on their size, insulation type, and installation method. When selecting conductors for a particular application, it's important to choose conductors that are large enough to carry the expected load current without exceeding their ampacity. Wiring methods include conduit, cable trays, wireways, and direct burial cables. Each wiring method has its own advantages and disadvantages, and the choice of wiring method depends on factors such as the environment, the type of wiring, and the specific requirements of the installation. Electrical boxes are used to enclose and protect electrical connections. Electrical boxes are typically made of metal or plastic, and they are available in a variety of shapes and sizes. The NEC specifies the requirements for electrical boxes, including the types of boxes that can be used, the full capacity of the boxes, and the methods for installing them. Electrical connectors are used to connect conductors to each other and to electrical equipment. Electrical connectors must be properly sized and installed to ensure a reliable and safe connection. The NEC specifies the requirements for electrical connectors, including the types of connectors that can be used, the methods for installing them, and the torque requirements for tightening them. Electrical labeling is essential for identifying and marking electrical components and circuits. Electrical labels provide information about the voltage, current, and other important characteristics of the electrical system. The NEC specifies the requirements for electrical labeling, including the types of labels that can be used, the information that must be included in the labels, and the methods for installing them. Proper electrical labeling helps to prevent confusion and ensures the safety of electrical workers and others who may come into contact with the electrical system. When working with electrical systems, it's important to follow safe work practices to prevent electrical shock and other hazards. Always de-energize circuits before performing any work and follow lockout-tagout procedures to prevent accidental energization. Use appropriate personal protective equipment, such as gloves and eye protection, to protect yourself from electrical hazards. Never work on energized electrical equipment unless you are qualified and authorized to do so. Regular inspection and maintenance of electrical systems are essential to identify and address potential hazards. Check for damaged wiring, loose connections, and corroded components. Replace any damaged or worn parts promptly to prevent electrical failures and ensure continued safety. Stay informed about updates to the NEC and other relevant electrical codes and standards. Attend training courses and workshops to enhance your knowledge and skills. By following best practices for electrical safety and adhering to the NEC requirements, you can create a safe and reliable electrical system for your home or business. In summary, understanding the NEC requirements for conduit, wiring methods, grounding, overcurrent protection, and other electrical safety measures is crucial for ensuring the safety and reliability of electrical systems. Always consult with a qualified electrician before making any changes to your electrical system.